This episode is sponsored by Celestron, manufacturer of high-quality telescopes and an industry leader in developing exciting optical products with revolutionary technologies.
I'm Kelly Beatty of Sky and Telescope magazine, and tonight we're going on a tour of the stars and planets that you'll see overhead during January. First, we'll watch one of the year's better meteor showers, then take up the challenge of spotting 5 planets, size up a celestial queen with an ego problem, and learn about a celestial hunter who also has an ego problem. So bundle up, grab your curiosity, and come along on this month's Sky Tour. Well, 2023 is behind us, and 2024 has begun. Every January, millions of us resolve to do something, anything different or better in the coming year. I suppose my resolution will be to get outside and enjoy the night sky more. It'll be tough. Often I'm too busy or too tired or, well, you get the picture. So how's about you and I agree to do more sky gazing this coming year, okay? We'll want to make good on that pledge right away, because a most excellent opportunity occurs in the first week of January with the arrival of the Quadrantid Meteor shower. These meteors get their name from Quadrans Muralis, an obsolete constellation near the handle of the Big Dipper, and they seem to radiate from that point in the sky. Viewed from perfectly dark skies, these quads can deliver at least 1 meteor per minute. In fact, in some years observers have reported seeing twice as many, but few of us ever see anything close to that for a few reasons. First, the shower's maximum activity lasts only several hours, and it's easy to miss. Seeing 25 meteors per hour is more typical. Second, for most of us, the radiant point near the Big Dipper is below the northern horizon until 1 or 2 a.m. And no radiant means no meteors. And third, bright moonlight will wash out the faintest quads, and this year a last quarter moon will hamper the viewing somewhat. But don't be disheartened. This year the peak occurs on January 4th at around 4 a.m. Eastern Time. That's very well timed for North America, with the radiant high in the northeastern sky. So if the skies are clear that morning, and if you're willing to lose a couple of hours sleep and bundle up against the cold, you should be rewarded with a nice sky-watching treat to start off 2024. Another celestial event occurs in the first week of the new year, though you can't really watch this one. On January 2nd at 8 p.m. Eastern Standard Time, Earth is closer to our star than it'll be at any time for the rest of the year, 91,400,000 miles away. Can't you just feel all that extra warmth? Honestly, being 3 million miles closer to the sun won't affect the temperature much. But it does mean that Earth is now zipping along its orbit about 2,200 miles per hour faster than it will be in July. And that does have a tangible effect, particularly on the times of sunrise and sunset if you live at higher latitudes. Here in Boston, for example, sunset comes a minute later each day throughout most of January. Those long winter nights are starting to shorten up in a hurry. Now, according to my celestial prognostications, it should be possible to see all 5 of the bright planets this month, but you'll have to work at it, and it might take a couple of days for you to bag all 5. Let's start over in the eastern sky before dawn. That's where you'll find the 3 planets closest to Earth. Most obvious is Venus, which has drooped a bit in recent weeks, but is still very obvious over the southeastern horizon starting about 5 a.m. or so. Beginning in early January, look 30 minutes before sunrise to the lower left of Venus by about the span of your clenched fist at arm's length. There you should see Mercury, which should be easiest to spot during the second week of January. After that, it'll slip a little farther down with each passing morning. Meanwhile, Mars is slowly rising higher in dawn's rosy glow, and the red planet should just become visible by month's end. In fact, on the morning of the 27th, Mars and Mercury will be just 1/4 of a degree apart. Honestly, though, you might need to grab some binoculars to spot them against the twilight glow. Now turn your attention to the evening sky. High in the south at nightfall is Jupiter, still quite dazzling as it slowly drifts westward each night. Now let your gaze slide from Jupiter most of the way to the western horizon, and you'll encounter Saturn, hovering low down in the southwest. If you have trouble spotting Saturn, the crescent moon will help you out. It'll be a bit below Saturn on the evening of the 13th and somewhat above it on the 14th. This month's full moon, on January 25th, is known as the Wolf Moon. If it's clear that night, stay up around midnight. Can you see how that big, bright orb is almost directly overhead? Full moons are always within 5 or 10 degrees of being directly opposite the sun in the sky. So when one is high up, the other is low down. And during northern winter, the sun struggles to get very high up in the sky even at midday, but the moon soars almost to overhead in our nighttime sky. Now let's talk stars for a bit. What's your favorite star pattern? It doesn't have to be a whole constellation. It might be any obvious arrangement of bright stars, what astronomers call an asterism. Maybe it's the Big Dipper, but right now that's lying low along or even below the northern horizon, depending on your latitude. Another obvious asterism is the 5-star zigzag of Cassiopeia. It looks like a squashed W in the summertime and like a flattened M in winter. After sunset, once it gets dark, face north and look almost straight up. There's Cassiopeia in its M position. It's a little wider than your clenched fist. Its left side is the brightest and easiest to see. This grouping is the Big Dipper's counterpart in the northern sky. In spring and summer, when the Dipper rides high, Cassiopeia lurks low. In fall and winter, it's Cassiopeia's turn to shine high over the evening world, while the Dipper sinks low behind the trees. All 5 stars in this M asterism are truly big and bright, outshining the sun by anywhere from 70 to 8,000 times. This impressive brightness, combined with being no more than a few hundred light-years away, is why you can spot this distinctive quintet almost at a glance from your driveway. In Greek mythology, Cassiopeia was a queen in what's now Ethiopia, and also the mother of Andromeda. This mythical queen boasted that she and her daughter were more beautiful than all the Nereids. Those are the nymphy daughters of the sea god Nereus. This was not a good idea. All that bragging brought the wrath of Poseidon upon the kingdom of Ethiopia, and there were terrible consequences. But that's a complicated story for another time. Ancient sky watchers not only subdivided the sky into constellations, but also gave each noteworthy star its own proper name. Some of these come from various cultures and flukes of folklore, but often they simply told the body part that the star supposedly represented in its constellation figure. For example, although the middle star in Cassiopeia's M has no official name, the ones on either side of it, plus the bright one at the left end, are named Kaf, Shedar, and Rukbeh. These are medieval European corruptions of the Arabic words for hand, breast, and knee. Now, during the 1960s, that middle star in Cassiopeia started to be labeled Navi on some star maps, and no one quite knew why. So here's the story. It turns out that 3 Apollo astronauts were learning the sky's bright stars as navigational aids, and they created a list that included Navi along with the names Rigor and Dinosus. Now, there was no lore of any kind using these names. It eventually came to light that the crew had played a little joke at astronomers' expense. Navi was the backward spelling of Ivan, the middle name of astronaut Gus Grissom. Rigor was the backward spelling of Roger, for astronaut Roger Chaffee. And Dinosus was the word second in reverse, honoring astronaut Edward White II. This story is both amusing and poignant. All 3 of these astronauts were killed by a horrible fire in the Apollo 1 capsule during a training exercise in late January 1967. Let's leave the Queen and shift our gaze about 4 fists toward east. That bright star almost overhead is named Capella. It's at the top left corner of an irregular pentagon of stars that outlines the constellation Auriga, though I think that Auriga is closer to its Latin root. This translates as the Charioteer, one of 48 constellations recognized in ancient Roman times. However, this pattern was first recorded long before that by sky watchers in Mesopotamia, who noted a constellation called Gam that represented a curved sword or crook. You can make out that arc using Capella as one end and then curving down and toward the right. Auriga has also been seen as a goat herder, first by long-ago Bedouins and later in Greek mythology. In fact, Capella takes its name from the Latin word for a small female goat, and just to its right is a faint triangle of stars sometimes called the Kids, as in little goats. To this day, the constellation Auriga has something of a split personality. Artists often depict it as a charioteer with a goat perched on his shoulders. But in ancient Hindu astronomy, Capella was important because it represented the heart of Brahma, the god of creation. Now, about 4/5 to the lower left of Capella, you'll see the stars of Orion the Hunter striding up from the horizon early on January evenings. In Greek mythology, Orion was a gigantic, supernaturally strong hunter who also thought very highly of himself. And he also had a lecherous eye for the ladies. Anyway, look in particular for a trio of bright stars in a vertical row. These mark Orion's belt, yet another asterism, and there's nothing else like them anywhere in the sky. To the belt's upper left is the bright star Betelgeuse, which marks the hunter's shoulder. Maybe you've heard it called Beetlejuice, like that weird 1988 movie? Use whatever works for you. Study Betelgeuse a bit, and maybe you'll notice that it's got a warm color, like weak ginger ale. That's because this is a red supergiant, a truly massive star that has swollen to tremendous size in its old age. But Betelgeuse still looks like a pinpoint in the sky because it's very far away, about 600 light years. This reddish star with the funny name was acting funny a couple of years ago. Betelgeuse had been getting fainter and fainter, eventually becoming dimmer than at any time since astronomers began measuring its brightness almost a century ago. At first they didn't know why this was happening or when the dimming would stop, but now they think that this star, already known to be an enormous churning cauldron of superheated gas, probably belched out a large cloud of dust that made it appear dimmer for a time. Betelgeuse itself was fine, though a little cranky. On the right side of the belt of Orion is the other really bright star, Rigel. Can you see the color difference between peachy Betelgeuse and icy white Rigel? It might seem counterintuitive, but icy white stars are the very hottest. Rigel's surface temperature is more than 20,000 degrees Fahrenheit, whereas Betelgeuse is only a third of that. Go figure. That's about it for this month. If you want more tips for viewing the night sky, including a free interactive star chart for any time or date, check out our website, skyandtelescope.org. If you haven't already subscribed, you can find this sky tour on Apple Podcasts, Spotify, Stitcher, or wherever you listen. And please, leave a rating or a review for me. It'll help others to find the show, and I enjoy hearing from you. And if you want to explore the solar system and universe more deeply, please do check out the full line of binoculars and telescopes available at Celestron.com. Sky Tour is a production of Sky and Telescope, a division of the American Astronomical Society, and is produced by me, Kelly Beatty. Next month, we'll spend a little time with the part of the Milky Way you can see in winter rather than in summer. Until then, I wish you clear skies.